Hey everybody, let's get started here. I don't know who's all here. Mubot is here. Mubot's always here. Unless I forget to load Mubot. Then Mubot's not here. But you've made 0 errors, Mubot. I make errors all the time. You know it, Mubot. So if you're here, feel free to say hi. We can work on whatever you want. I've made 71 errors this semester. People like to add and subtract those errors. But with this, let's go ahead and we'll look at some 320 here to start. I'm trying to think. Tomorrow is the 7th, so this needs the 8th on it. It does say that. I'm going to change it to that. Let's take a look at some 320 here to start. Let's hop over here to the main screen. Okay. Yes, Jessica's like, yes, 320. Let's talk some 320. Let's do it. So we're going to clear out our global environment here. Just get the global environment up and going and a little more space right here. So this first question right here, we do need the book for. I actually know the first question. I think we're predicting wins from something. It's talking about the residuals. So I'll pull up the book here real quick. So 2 seconds. Class is not over yet. Let me do homework packet. So can I find it? Really? So hard to find the homework packet. If you're looking for the homework packet, I'll show you where it's at. So the homework packet is going to be such a delay on that right there. The homework packet's going to be under the modules. So if we go over here to modules and we go to homework packet, and then we download right here, and then we just open up right here and we can view the homework packet. Okay, so the question we are doing is the EXNFL one. There's core demo. We're almost to it. Checking assumptions and models. Here we are. So let's take a look at this problem. Let's take a look at the chat too. Okay, so we're working on this problem here from the homework. There we go. Use EX3 NFL for the following problems. The number of wins an NFL team has. 11 years is tabulated in the wins column, along with 137 useful other statistics. Things like, their defense, their yards per play. All this other information is tabulated for us, so we can view tons of information about a team. Your results can shape how players are recruited and how preseason training proceeds. This type of analysis is everywhere in business analytics. Yeah, sports analytics is all over the place. Huge business. A quantity we're interested in, sales percent of people who respond to an ad, clearly should be predictable by something, but by what we don't know until we analyze the data. Technically, predicting wins, which can range from 0 to 16 for the NFL, is not a task for which we can use regression because the numbers of wins is integer. So what does it mean for something to be integer? It's going to be whole numbers. So we can see right here that if we have wins, and let's look at the distribution of the wins. So in EX3 NFL, the wins are integer values. You can see this as a histogram right here. This is just helping us kind of explore the data and understand what's going on right here. But we can see the histogram. If I go away, where's my go away button? There we go. So you can see the histogram of wins, and it's kind of normal. I mean, it's kind of centered around 7 or 8 because about half the teams are, that's about the middle for the teams right there, the middle ground. So we have here the histogram and reviewing it. Let's go back to right here. So with this, why does Y being integer value violate the assumption of the disturbances, that stands for the disturbances, being well described by a normal distribution with a mean of 0 and a standard deviation that is constant? So the issue here is not with the 0 because that's the linear assumption. The issue is not with the standard deviation sigma because that's the heteroscedasticity, no plot thickening, constant spread, one value for the spread. The issue is right here with the normality assumption. And you might say, well, this looks like a normal curve. But let's think about how this model end up looking. Let's go over here and look at the model. Okay. So when we have the wins, whatever variable we predict would be down here as the x. And then we're going to have integer values of y. So y can be 0, 1, 2, 3, 4, 5, 6. So if you go to a value of x, right, let's say right here, y could only be like this, 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 or this, or this. It's only going to go across those values. And you might have repeat values on some, but any sort of values of y are going to go across this, and you would see residuals like this. Now, hopefully I'm lining those up because those should line up. So, and we can just put lower ones down here, put the low ones down here. There we go. So this model is not so bad. I mean, we won't say it has heteroscedasticity or anything like that yet, But the issue is going to be the pattern of the residuals. Let's take one of these histograms right here and take a look at it. So we could draw this as a normal curve. We could draw this as a normal curve. We're pretending there's more dots here, like these dots have multiple dots. Draw this as a normal curve right here. So although there is heteroscedasticity, we're going to ignore the heteroscedasticity because I just wanted the linear model to look like it. The line should be going through it. We're going to take one of these normal curves, like let's take this one down right here and look at this normal curve. We're going to examine it. So examining this normal curve might look like this due to the repeated points. Something like this. It might look something like this. And if this is a random normal curve, then I want you to think about this. Let's say one standard deviation goes from here to here. If this is, it's not one standard deviation. We'll go from here to here. So if that's one standard deviation, this is 2 standard deviations, and then we go 3 standard deviations out. So this would be 68% of the data. Which it might be. That might be 68%. I have 10 points, so actually that's 80% of the data. But the issue really gets into what happens when we talk about an area like right here. This area right here has how many percent of the observations in it? It has 0% of the observations, just like even if we went further, this area right here has 0% of the observations. And it can actually never have any of the observations due to the y integer values. That area between, which I'm marking right there, probably it's the biggest area to kind of take note of, that area between there has none of the values. There's 0% of the values, and it should probably have close to, I don't know, 40, 50% of the values, maybe 40%. But 40% of the observations should randomly fall into there. But since y is an integer value, and maybe we're trying to say this falls between 4 and 5, wherever we're trying to say it falls between, you can't get values between this. Now, I'm not lining this up perfectly because my graphics, I'm not that good at drawing. But what I'm trying to show you here is you can literally not obtain these values. And the normal curve does not say that. The normal curve doesn't say, oh, you only get values here, and you only get values here, you only get values here, and you only get values here. There are no values between here that you can get. These values have a probability, and thus the normal curve is not appropriate here because of the integer distribution of the y. The integer distribution of the y makes it impossible for the residuals to follow this normal pattern because the residuals will have an integer pattern in them. Look at this integer pattern that goes over from 1, 2, 3, that the y values can only be certain values, and thus they can't properly fit under the normal curve. I hope, Jessica, this makes more sense. A lot of people were stuck on this one. I got a few mails on it already. So I was like, I've kind of explained it thoroughly in email. And also now I can point to this video and say, hey, check out this video. This explains how integer values of y make it impossible for them to follow the normal curve. Those values up there that are following an integer pattern cannot follow a normal curve down below. They would not follow the normal curve and have an integer-based pattern. So hopefully that makes sense right there. That's a really tricky one. It's a big question to start out with. Can you go over 3.1 and 3.2 on the... Yeah, sure, of course, Lauren, you got it. Let's hop right there and do that. Here we go. Coding practice night. So coding practice, day of review coding. That's not the one we did. Coding practice. Here we go. Is this the right one? This is the right one. Okay. 3.1 and 3.2. Write a for loop. Oh, we already... let's make these go away. Go away answers. We don't need you answers. Where we're going, we don't need answers yet. So write a for loop that creates a vector of numbers for 9 times 1 through 10. The for loop should display the numbers when it runs. There's lots of ways to do this, but exactly, Jessica, because there's values that can't exist. So just to finish off that, and then we'll hop to this one real quick. With the distribution we created, the normal curve cannot properly describe the residuals because there's impossible values that you would not obtain. And so the disturbances, which are the true residuals, would not possibly exist with this normal curve. They can't exist. Does that make sense, Jessica? These values I've marked in the green just can't occur. Yeah, sure. We can do that here next. You got it. We'll do the questions here, and then Gigi, you got it. We've sent out I've sent out a thing last night, but we will do that one. 2 customers getting cards from the drawing. I think that's a really tough one. Oh, is it talks about customers getting cards for a drawing? That's the one. Can you do the quiz on chapter R? I can't figure it out. It's the one with the lottery website notes, the long run. Yep, you bet. That's going to be 201, is it? Oh, so good to see everyone here. We're going to do 3.1, 3.2, then we got Gigi's, then we got Macy's question. You got it. We're going to do all the questions. Thank you, everyone, for being here today. Some days it's a little slow, and today's we got people here asking questions. Love it. So we just say, wow. Let's do this. So here we go, 3.1. The most important thing is going to be writing the code for this. So we want to, and I think Dr. Lou did it right, and I made one error. I've got one number off in my key. We want to write here 9 times 1, and that just solves right there. But we want a for loop that goes through 1 through 10. So this is our skeleton, and then we write 4, and we go right here, and we're going to make it so this 1 changes. That's now an I, and it's going to go through the values 1 through 10. So we can do a few easy ways of making this appear by going here and going to print, and this is the easiest way to do this. So this prints out the numbers 1 through 10 and multiplies them. I'll show it right there. But that's probably the easiest way to do this question, is to write a code that just goes through. And it's important to know that this will change what I is. Every time I runs, I starts with 1, and then it goes to 2, and then it goes to 3, and then it goes to 4, then it goes to 5, 6, 7, 8, 9, 10. So every time this loop runs, it always moves I over 1 position in this vector. This is the vector of numbers that I takes on. I is the placeholder, which is replaced with the vector of numbers. So understanding what the code does is important. It just makes I1 runs the loop, makes I2 runs the loop, makes I3 runs the loop and goes through, and then makes I10 runs the loop, and then it ends. So that's probably the easiest way to do that one. Using the mtcars data frame, we can overwrite the current data frame if we want. Causes issues for later ones. So I'm going to do it this way. Hey, what's up, Dan? Good to see you here. We're about to do some 201 here in a moment, so feel free to ask some questions and everything, and we'll be doing some 201. Good to see you here, Dan. Make Macy a mod too. Macy, you are now also a mod. So with the mtcars data frame, we're going to simply go to the new data frame we just made, and we just created the data frame from the current data frame. So all this does, if you're 201, you're wondering what the heck does that code do? That just creates a copy. So I took something and I said, create a copy of it. It's just store this into this, and it just creates a copy of it. So I could call it this, and then I got another copy right here. It's just a copy of this data frame, which a data frame might as well be an Excel spreadsheet. So it's basically just saving an Excel spreadsheet with another name and making a copy so you can do something with it. Understanding what your code does is very important. So now when you see this, this is going to the first row and the first column. And you can see here the 21. So this is first row, first column. Oh, perfect, Dan. That's excellent. First row, first column. Watch as this says 21. Are you ready? 21, because it's going to the first row, first column. What this code wants us to do is store into there. So that's the store into arrow. And we're going to store into it half of the value of what was there. So this takes half of the 21. Half of the 21, so we should get 10.5, and then this writes it into that position. It says store into that position. So now if we check what's in this position, we see the 10.5. But this code wants you to do it with a for loop, but good question here, Lauren. We've just created our what? Stat Nation reunion. Let's go, Keaton. So good to see you here, Keaton. Thank you for showing up, Keaton. We have new MuBot. So we're going to make this a for loop, Keaton. Check this out. You ready? MuBot, calm down. MuBot gets antsy. MuBot's got problems. Oh yeah, thank you, MuBot. That's much nicer. MuBot has a lot of quotes. So what we're going to do is we're going to turn this into a nested for loop right here. So I love it. And so we're going to go right here. We're going to make this the rows, and we're going to go from 1 through the number of rows in mtcars, which is the data frame. All this does is just tell us how many rows and makes a number vector of rows. We're going to do the same with the columns. And so this just goes 1 through the number of columns. And then we're going to put here C. Now these are the placeholders, because when I run this loop, R and C will change. So R will become those numbers and C will become those numbers. So we go right here and we replace this with R and replace this with C. Replace this with R and replace this with C. Because every time the loop runs, it'll change. Oh, we need to get the merch. We need Stat Nation shirts. If we could make some Stat Nation shirts for pretty cheap, that'd be amazing. And there we go. It could just say Stat Nation. Just like, what if we could do UT Orange and just do Stat Nation across it in like a $5 t-shirt? If we screen printed them, we could. I need to talk to students. Maybe I'd let students like just make the money off of it. I don't need to make money. I think it'd be cool to have merch. I don't need to make money. So if we could do $5 t-shirts, and you could just get a Stat Nation t-shirt, just UT Orange and then black across right here, or we'd have to do gray because the other color's gray or something. But just orange and Stat Nation across, like right there. Just boom. Like, what's up? I took this class. We'd be like, I got a t-shirt from my class. And then we could give away some t-shirts. I don't know. Ideas, I like it. Let's make a basketball jersey with Stat Tool. And oh my gosh, yeah, but if I could only play I'm 6'3". I was going to say 5'3". I'm 6'3", but I can't play basketball. I'm horrible at basketball. So this is the code right here. I think it was, who was asking that? Lauren. So let me drop this in the chat, Lauren. Oh, it's in the key too. We've posted the key. But now we've got some 201, I think it is. Question 2 on the randomness. Let's hop over here to question 2 on the randomness quiz. We'll do this. Okay, let me leave all this. Okay, we're going to go to 201 on the randomness quiz. Let me go find that. Everyone relax in the chat. Oh, I've got mega. Wait, did I change the musics? No, we got music still. Haven't used these lately. Bring it down a little bit there. I like using this music because I know I won't get hit with a copyright. Nintendo is so nice. Now Nintendo's gonna hit me with a copyright. Nintendo's gonna be like, you think you're fine? You think you won't get hit with a copyright? Too bad. Copyright. This is Mega Man. We are loading up. We're almost there. What? We almost did it. We can do it with this. The Zulma noise. We will do it right into that time. Randomness quiz. Replace questions. No! I was so close. So close to doing it. I was seconds off there. Seconds off. I saw the playlist for some randomness questions, but could you go over more? Yeah, of course. If you get more than 10 trials on the dice question, remove the trials. Jasmine, great question right there. So Jasmine, if you get more than 10, remove those remaining. Does that make sense, Jasmine? The 12-minute long question. Which question do people want me to do? We're doing randomness quiz right now. We can do this one. We can do any of them. But Jasmine, really good question. If you get more than 10 trials, remove the remaining trials. If you get more than 10 trials, remove the remaining observations. The customer's getting the cards. Ooh, this is a fun one. It's probably my least favorite one. Don't worry, I'm gonna do it here, but it's my least favorite one. It just takes the longest to do. Okay, cool. We can copy these to clip. Yeah, that's the way of doing it. Okay, so with this, there's a few ways of doing this, and the children. Yeah, I can do that one next. We'll do that one. We'll keep doing as many of these as people want. So you guys are here. 201s join the room. 201s join the battle. So we can do this, and we do the lottery one too. That's one of my favorite ones. So I just dislike this one because it takes a while and it's so easy to make a mistake on. You bet dice roll coming up. So when we do this question right here, I think I coded this one. I don't have my solver. I have a solver for this one too. Of course I coded it, right? But let's go here and we're going to put the numbers right here. Oh my gosh. So when you work this problem, okay. So what you want to do, find and replace is your best friend. Find and replace is your absolute best friend for these problems. I think we can hit Control F or Command F. You can do it manually, but find and replace is the best. We're going to go to replace and does not have the advanced. Here we go. This is what we want to use. You need to use the advanced or else it'll mess it up. We need to find whole words only, and then we're going to find 0. Now we need to look at the problem to make sure we're doing it correctly. And if something is 0, then people got, where's 0? $20. 0 through 5 is $20. You must make sure that you're doing find whole words. Does this make sense? because we're going to take 0 and turn that into, let's double check, $50, I believe, right? $20. Good thing I double checked. 0 through 5 is $20. So we're going to go here and go to replace all. Now we're going to go to 1 and replace all. 2, replace all. 3, replace all. 4, replace all. 5, replace all. Does everyone understand what I'm doing here? I'm taking the numbers and turning them into their actual amounts. And make sure you're using find whole words. This is Control F or Command F if you're on a Mac or a PC. So we're converting these into their actual amounts. Now 6 is it $50? I think it is $50. Is 6 and 7 are 50? I think 6 and 7 are 50. 6 and 7 are 50, and then 100 and 200. So we're going to go here, replace all. Go here to 7, replace all. Go to 8, 100, replace all. And go here to 9 with 200. Don't make a mistake. It'll mess up the whole problem. There we go. So that's got a lot of the work done for us. Now we just have to play the game. So every simulation has rules to it. Whenever you're doing a simulation, you have to know how you are simulating, and you have to understand what the rules of the simulation are. If you don't understand the rules of the simulation, you fail the simulation. The rule of this simulation is you have to give away more than $400, I believe. Let me double check. They are going to give away, where's the amounts? Okay, here it is. Until the store has given away more than $400. So you do not stop at 400, you give away more than $400. They're going to do 10 trials where they give away more than $400. So I need your help, audience. I need your help to solve this. Are you ready? Here we go. What we're going to do first is we're just going to count 50, 70, 120, 140, 190, 210, 230, and look here, 430. I'm going to hit enter. Does that make perfect sense what I did? Did everyone see exactly what I did? I just counted up the money. And so now be careful. How many trials do you think we will perform here? I'm going to do this one in my head. Try to do it in your head. Just go down here and go. Okay, wait, I'm not going to let you see my cursor. Okay, I got it. It's kind of obvious where you stop. Where do we stop now on this one? It might be 10 trials. It's right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great job right there, Macy. Excellent work. 10 trials. And this one right here, you can kind of tell where it's going to probably end. Be careful. 100, 120, 320, 340, 360, 380, and then that's 430. So that's a trial right there. You can probably just bring this down to the next page if you want, so you don't have to go between pages when looking at it. 50, 70, 90, 190, 210, 230, 330, 350, 450. There we go. Oh my gosh, all these 20s, you got to hate them. People getting $20, it's not fun. 20, 40, 60, 80, 100, 120, 140, 160, 180, 380, and 480. And then let's go next page on this, just so we can view it all on a page. 100, 120, 170, 220, 240, 260, 280, 300, 320, 340, 360, 380, and 430. 100, 120, 170, 220. Whoa, it's 220, I believe. It's 220, I can tell. 240, 260, 280. 330, 350, 370, and 420. And again, another page. 220, 270, 290, and there we go. That's trial. That's 90, 140, 240, 260, 310, 330, and 430. 60, 160, 260, 300, 320, 340, 360, 380, 400, and then that's the last one right there. I'm going to make an executive decision to do that. And see why I hate this problem? This is the least fun problem. It takes the longest. Even if you're quick, it takes a while. 90, 110, so 90, 110, 160, 180, 200. Oh, might have done it. This might be the end of it. We might have ran out of trials. Oh, no, 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 no. Yeah, we're good. Okay, it looks like that was the 10th trial. So 1, 2, 3. Yeah, that's one across the page. 4, 5, 6, 7, 8, 9. Uh-oh, uh-oh, uh-oh. Oh, no, 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 no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 trials. Okay. It is 10 trials. We did do 10 trials. I don't know where I missed a trial counting. Now, what you can do is you can count up how many numbers there are. So you could actually go through and count all the numbers. But remember, like we talked about with the other problem, you want to delete the extra numbers. So we've deleted the extra numbers at the end. If you didn't see at the very end, I had these numbers here, which were extra. Delete those off. And then you can go down here and go to count the words. So there are 97 words. And I don't think it's counting the spaces right now. Yeah, it's not counting spaces. If you look, I did a whole bunch of spaces right here. And if I do that, it'll say there's 98 words. So there's 97 words with, oh, well, sure. With 97 words and 10 trials, on average, how many did it take? This is the grocery store giveaway question. The grocery store giveaway question with 97 words, which is right here. There's 97 words on this screen and 10 trials. 97 words and 10 trials. How many trials did it take on average? 9.7. Let's cross our fingers and say, not today, my Pearson. Not today. Can we not check the answer? Woo! Not today, my Pearson. Not today. That's the grocery store giveaway question. That didn't take that long, 7-8 minutes. But I've solved these problems. If it takes me 7-8 minutes, that's a long time to solve a problem. Do you have any last minute tips for 4 coding night? Yes. Have your notes organized. Have your notes organized, Jake. Really good question right there. Have your notes organized. Glad it makes a lot more sense. It's a tricky question. The big thing is converting these numbers into their what they are. Convert them into the dollar amounts, and then just be very careful as you add them up. I was like thinking I'm going to make a mistake, and then I've done it before. I've made a mistake. Shout out the one you want next. I saw a whole bunch, but if you're here and you're present, you get to choose. So yeah, the word count, that's the easiest way to do it, because you could go through here, and what it's doing for you with the word count is it's literally going 1, 2, 3, 4, 5, 6, 7, 8. It's counting them all up. Beth and Nate, they want to have kids. You got it. I can solve that one in 20 seconds. Don't believe me? Watch this. Time for a Stat 201 speed run. You knew it was coming right there. 20 seconds solve this, and I'll explain how to solve it. Yep, we can do number 2 next. You got it. Wait, we got the speed run timer so small. I need to change the fonts back on this again. Let's do it for the videos. 20 seconds solve. Here we go. Let's do it. We're going to go copy to clipboard. We're going to copy it. We're going to go over here. We're going to go there. We're going to go here. We're going to go everywhere. We're going to go there. And that's 6.9. And so 6.9. And how many trials did they have? So 20 trials did they have? 69 divided by 20. 3.45. Did I do it? Solve it. There we go. Right over 20 seconds. Okay, let's explain how this problem is solved and what they're doing right here. Okay, so Beth and Nate are going to have kids until they have a boy and a girl. And so in this simulation, a 0 or 4 represents a male, and a 5 through 9 represents a female. So when you look at this family, do you see your family on here anywhere? I'm trying to see if I see my family right now. Oh, I do see my family immediately. My family is right here, and is that correct? Wait a minute. Let me double check. Yeah, that's right. Why is my family right here? And actually, I'm right here. I'm number 3. So can anyone tell me about Brian's family? Convert that into what it is. You always don't look at it as the numbers that it is. Look at it what they're trying to show you. So what family is this right here? Can anyone explain about Brian's family? Because I'm right there. Can anyone tell me who's in my family? 2 boys and 1 girl. Yep, I have an older brother and a younger sister. So there's my older brother, there's me, and there's my younger sister. Now, this family right here, could you imagine a family being like, we're gonna have a boy and a girl, and then they're like, boy, 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 girl. This is almost actually, this is my mom's family because she has 3 sisters and 1 brother. So that's my mom's family right there. It was girl, 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 my mom, and her brother. So when you look at this, you maybe can see your family structure in here somewhere. And then you have some families where you just have a girl and a boy or a boy and a girl. Yeah, that's right. Girl, boy, boy, girl. So what's going on right here is they're doing 20 trials of this. In this simulation, they're doing 20 trials to see like a what if scenario. Does that make sense? And then they're asking on average for the 20 trials, how many children did they have to achieve their goal of one boy, one girl? So with this simulation right here, all I did, if you saw me go over to the Word document, was I found out how many observations there are. There are 69 total observations due to the number of characters. Does that make sense? There are 69 total. You could add them up, go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and go others. 69 total, and there was 20 trials in the simulation. So then I said, okay, with 69 total observations and 20 trials, then it was 3.45 on average per simulation. So on average, it took 3.45, and we got that by finding out how many total trials how many total runs there were, or how many total attempts there were, and divided it by 20 since we had 20 total simulations. Is this one making more sense right here? Who's like, okay, got it. This one, don't worry. Once you see it, it's like, oh, that's all they're doing. Is they're saying on average how many children did it take for them to have a boy and a girl, and they're making it more complicated with everything. Yeah, hopefully that one makes more sense. And can you do the different state one, please? Yep, you bet. Was that number 2? We saw it earlier. Number 2. Number 5. So an elementary school teacher has 25 students, and they want to assign each state. I mean, they could just put them in a bag and say draw a state. That'd probably be the easiest way. But they're going to use random number generation because we love random number generation. And so states have numbers 0, 1 through 50. This would be like Alaska, and that'd be Wyoming, maybe Alabama. Alaska would come for Alabama, right? Alabama. So Alaska. Yep, Alabama would come first. Is Alabama the first state alphabetically? I think so, right? Alabama because for Arkansas. You'll have to correct me if I'm wrong. And Wyoming, I think, would be the last state. It is. Wow. I got something right. Early on in my education career, I got something wrong, and a student was like purposely mean as a joke. And he's like, how do you not know that? It's really sad, Brian. You teach here and you don't know that. I was like, what the heck? I should just want to get out. He'd be like, how am I going to get out? He starts saying, I'm messing with you. We'll do the birds effect one next. You got it. The website one, you got it. We'll do all these right here. Okay, and I have a playlist if you want to rewatch, and I go through them again, but I do not mind helping out right here. No, like, tell people this video, it's got help. We're going to do as many as we can. You're here, you're asking the questions. Boom. And I'm so glad to see so many people here. The random digits are blah, 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 blah. So what really confuses people about this problem is the way the random digits are organized. Here's a better way to do this. And I wish we could, oh man, my Pearson, why do you do that? My Pearson really is bad about copying sometimes because the way they generate the numbers, it doesn't let you copy them. Okay, good. So you have to go through to copy them. Let me show you again how I copy these. And be careful, I've seen them double copy. I don't know if they fixed that. But when you copy these numbers, you have to go through them. They will not highlight, but you have to go through them and delete out the extra stuff. Be very careful because I don't know if it's Macs or if it's non-Google Chrome, but I've seen them double copy, and that's actually in my videos. And it was doing it on the PC last semester, so I don't know. How do these problems appear on the test if you're not allowed to use a word to help out? They'd be simpler. I'll show you a good one that could appear on the test. A good one is the student is taking a multiple choice question thing. You do get a scratch sheet of paper, so I wouldn't, they're usually smaller, and this one's a good example of a problem that could appear on the test, and it's a lot smaller. Does that make sense, Ashina? So it's Ashna, right? Make sure there we go. This is what we want to do right here. There we go. So what did I do? I took the states and put them into 2-digit number combinations. Does that make sense? The states are now 2-digit number combinations, so we can actually talk about what states the students would get. So when awesome, thank you very much. I want to make sure you're right. So when we look at these 2-digit number combinations, what do we notice right here? Is 22 a state? Yes. Is 73 a state? No. Does anyone see anything else here that's not a state right now? I see 3 more that are not a state. What would not count as a state? What would not count as a state? 89, you got it. Boom. 97, 72, there we go. So now we have our list of numbers right here, and we go to student 1 and student 2, and student 1 is going to immediately get 22 and 43. Student 2 is going to get 0, 6 and 43. Someone stop me. What's going on? What's the teacher going to say? What's the teacher going to say right here? If you notice something right here, something to notice. What's the teacher going to be like, ooh, wait a minute here. Repeats. So we don't want people to do the same state. We want to do this right here. So we're going to skip this. You could actually delete that if you want because it's a repeat. And then this one's not needed. This is technically, if you're continuing the problem, student 3, because there's more students, but we don't have more data after this. That's what, yep, choose different states, yep. And so this would be the full answer right here. It goes beyond the problem, but they're just going to simulate numbers. And it'd be so much easier to do this. You could just literally, this is why R is so easy and makes life so nice. I could just go here and go to sample 1 to 50. I could say, okay, you're getting state 25 and 43. That looks a lot like what we got. Very close. Wow, that'd have been so weird if it was 22 and 43. But I could easily choose the states for the students with R. I could say, okay, let's see who gets what state. Boom, there you go. There's the order of your states. You are student number 1, and you can just do it alphabetically because it doesn't matter the alphabet. And the last student here, the 25th student, would get these 2 states, and we'd have no repeats. So, yeah, we can do the lottery one. Is it the lottery? I think someone, which one? We're going to do the lottery one next. We can do the lottery one. So, but just, I love showing off the power of R because in seconds, you could just say, okay, the first student gets 25 and 43. And you could just do that. 22, 43, 06, 09. Coding is basically the answer. Yeah, coding. It's like, yeah, code it. And it just makes life easier. And it's such a simple code. But I mean, if you don't know how to code, it's all right. Because then it'd be like, what the heck's the code? 06, 09. Please tell me if I make a mistake. The website one. Oh, people want a birth defect one next. So where's birth defect one? I think I saw it earlier. That's a stupid one. I hate this one. The theoretical can... Wait. But for each coin flip, it cannot be predicted. Where's approximately... There we go. Go away, stupid question. It's my least favorite question on this whole thing. Even more than the longer one. Is that... We're going to do the birth defect one. Here we go. Okay, so with the birth defect one, we have to first figure out the probability. So the probability here needs to be deduced from 27 over 300. So what is the probability here? The probability, according to this problem, is what percent of the probability, or what percent of the time would people have a baby with a birth defect? According to this problem, a birth defect would occur what percent of the time? Yep, we'll do the lottery one. You got it. 9%. 9%. Great question. So good to see everyone here. Who we got watching? What? 0 viewers. Nobody's watching. 9% of the time. Okay. So when you think about 9% of the time, 9% would be numbers 1 through 9. And I think this is what confuses people. Nice. 14 people. I like it. Oh, because I didn't do stream modes right today. That's my fault. So 9% of the time would be numbers 1 through 9. But if you do it with 0 to start, it'd be 0 through 8. Just so you can see this, let me show you right here. And let's clear this out. This is what I'm trying to show you. We're not learning about code. We're not learning how to code. I'm showing you right here that this is how many numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8 is actually how many numbers right now. 0 and then 1 through 8 is how many numbers. 0 and then 1 through 8 is how many numbers? It'd be, because 1 through 8 plus 0, so not plus, but another number, it'd be 9 numbers. So there's 9 numbers right here. And then you might wonder, well, why do they do this? And I wonder, R's not going to do that. I got mad. The reason we use 0, 0 is because it's a 2-digit number. And 0, 0 might as well just be the 100. And I wish it did the 0, 0. But you can display it as a 2-digit number. And that's when people use like random number tables. They generate 2-digit random numbers, and 0, 0 is a random number. So 2-digit random numbers are still 100 combinations. There's 100 combinations of 2-digit random number combos. So they're going to use a 2-digit random number combo, and they're not going to skip any numbers. And so they're going to start with 0, 0, and they're going to go all the way to 0, 8. And I think that's what confuses people about this question. Is like, well, why are you going to 0, 8? Because you're going 1, 2, 3, 4, 5, 6, 7, 8, and then you're adding on 0, 0, which is the 9th number. So where will this start for the babies that don't have birth defects? Well, the 9% are going to have birth defects. The 91% are not. So we're going to start at 0, 9 and go all the way to 99, which is the remaining percentage right there. Does that make perfect sense? I think the confusing thing is, why is it 0, 0 to 0, 8? It's just doing 9% of 100 numbers. And 100 numbers going from 0, 0 to 99, if 0, 0 is the first number, 0, 8 would be the 9th number. Just think about two numbers. 0, 0, 0, 1 is two numbers. You're all going to 0, 1. Awesome, Hunter. I'm glad that makes more sense. Yay. And then Trace wanted first the lottery one. Wow, look at how many we've done of these so far. Is this the lottery? This is a good one for a test. That's a good test one. The dice one. Off topic 320 question. When you use eval false, the excessive output pops up in the RStudio, but it will not knit. Jessica, 100% right there. And also eval false will not evaluate when you knit. So make sure you, if you load something in there, like if you load a data thing, that you make sure if you load data, you load it somewhere else, because it won't evaluate when you run it. So does that make sense, Jessica? So the website one, which one? Here, we'll do the remaining order ones. You ready? No one's asked about this one, so we'll save that for last because we got just enough time. We're fine. So let's do the dice roll one. The dice roll one's a lot of fun. I love the dice roll one. It is my favorite problem because it's our first really tough problem that we ever added to the randomness chapter, and then I added all the tough ones. If you want to be mad at someone, be mad at me. So what I'm going to do right now is I'm going to copy the numbers. So please note how I'm doing this. You have to go right here, and you have to go through, and you have to copy. Now, I wouldn't copy the 9 because some people are going to think the 9's a number. Well, good thing is we delete the 9. So I'm copying it, Command-C or Control-C. And then I'm going to go over to Microsoft Word afterwards. I'm going to paste in a new document. And then I'm going to delete off this extra stuff. If it double copies, make sure to delete the double copies that is in my video. They might have updated it this semester because it's not double copying for me. But it used to double copy. When I did this problem in Seth 2 and it took so many tries, it kind of turns into a fun game. What? Yes, Jessica remembers. I love it. Jessica, watch. I don't know if I showed you this yet, but I can solve it super quick. So when we do this problem right here, with dice rolls, what numbers do dice have on them? What numbers do dice have on them? Dice have numbers, Jessica, 100 points. Thank you for being here and hanging out. Everyone gets 100 points. 1 through 6. So we're going to hit Command F or Control F, and then we're going to go here to the down arrow, and we're going to hit Replace. So we're going to replace 9 with nothing. And we don't want to find whole word. We're just going to replace in here. We're going to need to remove this. This will replace all your 9s with nothing. Watch as they get deleted. We're going to replace 8 with nothing. We're basically just deleting them. Now, you could delete them yourself, but this is more exact. It's just way easier to do that, and then they're all deleted. That's awesome. So if we can automate it. So now we only have dice rolls on here. So now we're almost done. We just have to know how to play the game, which that's what Jessica says, the awesome part, and I agree. When you play this game right here, you're playing a game of sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the home space, and you have to move 10 spaces. So we're going to try to move 10 spaces to get home, and our piece starts out right here. So this is our piece right here. So on our first roll, we roll a what? I need to see it in the chat. What do we roll first? What do we roll first? We roll a what? What do we roll? I can't read. A 5. Thank you, Ashna. Excellent work. 1, 2, 3, 4, 5. We roll a 5. So now we roll a what next? Oh, I need all the help here. What do we... Oh my gosh, I'm going to hit all the buttons. What do we roll next? A 3. Great job, Ashna. Great job, Layla. 2, 3. Now, here's where it gets confusing. We roll a 5 next, but does everyone see where we're at? Can we move 5 spaces, yes or no? Can we move 5 spaces? Can we move 5 spaces now? No. So we skip this. I usually just say over or skip. So when I'm doing this, I'm like, skip, yep, skip it. And then we get the 2, and then we've gone home. So that is one trial right here. So that is one trial done. And now let's go back here and do the next trial. And we'll do this also by counting it out. This one's a little bit easier because we roll a 4. So 1, 2, 3, 4. Then we roll a 5. 1, 2, 3, 4, 5. And then we actually have to roll a 1. So because of that, we actually have to roll the 1. Does everyone understand what we're doing right here? Does everyone understand pretty well what's going on? Hopefully it makes sense. You can't go over. If you go over, you just skip it. So a 6, over, and then a 3, and then we get a 1 right here. 1, 5, over, 7, 8, over, and then 10. So just make sure you're doing it properly right there. And as long as I don't make a mistake. I made a mistake yesterday and lucked out. That's 10. That's 10, 2, 5, 10, 9. Once you get to 9, you have to get a 1. That's 10. That's 10. Delete the extra numbers, and there's the answer. Now, you could count all these numbers and divide by 10, or you can hit the words button and see that there's exactly 50 words. And with exactly 50 words, we're going to divide 50 by 10 because there were 10 trials, and we divide 50 by 10. Now, how could I make this simulation more accurate? So we get 5 average trials. How could I make this simulation more accurate? Oh, such a bummer. Hey. No one touched my arm. It's always fun being on camera and being like, more trials, exactly. Include more trials. Thank you very much, Layla. So, more trials would make it more accurate. It's a way to make a simulation more accurate and better. We showed yesterday. I wish it would copy. So watch this. We're going to speed run this one real quick. So here you go. Here's the speed run of it. I think I still have the code up. So we go here. We delete off this stuff. And I got under 20 seconds yesterday. And then I don't have the code right up right now. No. It's going to take so long to get back to the code. Where did I save those numbers? I didn't save those numbers. Did I save them as numbers? Did I save them as numbers 2? Where did I save those numbers? Oh, did I not save? Oh, they're there right there. What are they called? Numbers what? Numbers 3. Oh, I should just type numbers 3. Oh, and then you give the graphics error. That's a big graphics error. There we go, 5. Yeah. So this right here, I wrote some code. What happens if there's not 10 trials? There has to be. I've never seen it not. Maybe there's an error, but I've never seen not an error. We did way under a minute. I'm blocking it right now, though. But I can also usually solve it by myself. We saw yesterday I can solve it in about a minute. That one's not so bad. Just make sure to carefully do it. It takes practice. You can solve it pretty quickly. I wrote code that solves it for us, though. So I had one that had 7 trials. Really? Oh, you might not have copied the second number line. Make sure you have the second number line copied. This one is the edge of a fair test question. It's really tough. It's just easy to make mistakes on. It's on the edge of what I would call a decent test question. A little too much work, in my opinion. Let's go to question 8. See what that is. Ooh. Yeah, I should do this one again right here. This is another tough one. This is another tough one. Yeah, I know, right? I love them to, like, in Stat Lab especially, you see people be like, I'm on the dice roll question, so I'm like, I'll help out. So this one right here is a tough one. This one, I'll let you in on a little secret. I've taught instructors how to do this problem. Just saying. It took me a while to be like, wait, what are they doing? What are the rules of this game? So this one is also another very tough one. So if you luck out on your quiz, you get 5 attempts at the quiz, and you can get a quiz version that the quiz version you want is not to get this one and not to get the grocery store one. The grocery store one, this one just has a complicated rule or two. And I did a really good job I've got a video where I lay out all the rules for this. So I might drop that in the chat. Oh no, maybe I did that in my office. Let me see if I can write down all the rules for this concisely. Okay. So you have couples showing up to play a game. And they're all going to get on different teams. Rule 1, couples cannot be on the same team. So you've got person 1, person 2, person 3, person 4, person 5, person 6, person 7. And notice I did not, and person 0. You do not have person 8 and person 9. Rule 2, person 8 and 9 are not there. Rule 3, if you have 4 couples paired, wait, 3 couples. 3 couples paired, deduce the last, or yeah, figure out. That's a confusing rule. If you already have 3 of the 4 couples, you have to figure out the last one. I think, oh yeah, I think this is all, will this video be put up? Yep, this video is up right after it's over, and you can always rewind live and stop live. So good questions there, Macy. This video will be up so you can review at any time. So, and feel free to hop into office hours and say, hey, can you work this problem? And then you get a video of it to review. So feel free to swing by anytime you see me live, and I try to, whatever assignment people are working on, I try to focus on that the most, or the most, pressing issue for classes at that time. But no, and I'll always answer as many questions as I can too. So with this one, I think I have all the rules written. I think I do. So let's play the game. I thought there's a 4th rule. I just can't think of it. So when we start pairing people together, I could put, well, it's kind of obvious. You can only pair people 1 time. Rule 4, you can only pair a person 1 time. Okay. So we're going to pair together people 1 and 6 to start. That means this one cannot occur. Then we're going to pair, Rule 5. 0, 1, 2, 3, 4, 5, 6, 7 came together. Okay. So the goal of this is to pair people with different people. I think I have every rule I could possibly describe to you right now, and it will illustrate what we're doing in the game. So when I get to 5, 1, what would you say for 5, 1? 5, 1, can I pair together 5, 1 right now, yes or no? Who can tell me what decision Brian's going to make? Is he going to pair together 5, 1 or not pair together 5, 1? Will I pair together 5, 1? If you get 400 on the dot for customers getting cards, over 400, GG. Good question. You have to get over 400. That's messed me up on that question before. And I can't pair these 2 people together because 5's already paired and 1's already paired. Can I pair together 4, 9? Yep, because I've already used 5 and 1. Bingo, exactly. 5 and 1. If you've used either, just to be clear, if you've used either, you can't pair them. Would I pair together 4 and 9? Now, 4 and 9 have not been paired, but look at all my rules. Look at all my rules I've laid out about this, which is kind of told you in the problem, but not in this kind of clear format. Can I pair together 4 and 9? 4 is not paired with anybody. 9's not paired with anybody. Can I pair together 4 and 9? Correct. Ashton, excellent work. And because 9 is not at the party, exactly, not there. So 9's not there. So that's a no. 5's already been paired. 7 and 3. So once you get this pairing right here, I usually ignore what's been done. And I look to the problem and I say, okay, 2 and 4 are the last 2 to be paired. Sometimes you'll see it, sometimes you won't. This is where it's confusing. I don't even need to see that. I could just go here after it and write 4 and 2 because that's the only people who can be paired together now. Because, does this make sense? Even if 4 and 2 is not listed, which sometimes they do that to you, which makes it really confusing, 4 and 2 has to be paired together because there's no other people who could be paired. And this right here is a successful trial. This is a successful trial because, and I'll maybe just put 1 green mark on the trial. This is a successful trial because everybody was paired with someone different. Let's look at the next trial right here. And the first group cannot be paired. And then the next 2 can be paired. This and this. What happened? What happened? I'm stopping it. Game over. What happened? What happened right here? Why am I like, nah, stopping the trial? Because we're seeing how often we pair people with completely different people. And so what happened? Yep. So that's not like an error. It's just you didn't pair people with completely different people, which is the goal of this simulation, to see how often that occurs. And since I have now paired together 2 people who came together, I'm just stopping the simulation and saying, okay, moving on. Next question. So now we go here and we pair together these 2 and then say no. That person's already paired. And then we pair together these 2. They're not here. You can't pair with yourself. 0 and 3. I think 0 and 3. There we go. And then we have 6 and 7 up. So this is the one you have to deduce. And 6 and 7 came to the party together. So that's a no for this trial. That was a tricky one. That's a tough one. So you have to deduce 6 and 7. Why wouldn't it stop after 2, 3? Are you talking about for the one up there, the second trial? It never made it to 2, 3 because, or for 2, 3 for this. Oh, because 2 and 3, 2 is already paired. So the reason we didn't use this one right there is because 2 has already been paired with 4, so we didn't use that one. In the lottery one, you bet, Trace. I bet we got enough time. We got enough time. Class doesn't start till 1:50. I'm going to eat after this. But we don't use that trial because 2's already paired with 4. Yeah, no, great question. It's super, like, you have to be very, very careful. Like 4 and 5, yes. Oh, this is awesome. 4 and 5 we pair together, but we stop the simulation right here because 4 and 5 are already paired together. Next, I think I know which lottery one you're talking about, Trace. It's a good question. 3 and 8 can't be paired together. 2 and 6. And this is another instance where we've already paired together a number, so we can't pair that. Those numbers don't exist. Those numbers don't exist. Those numbers don't exist. 1 and 2, 2 is already paired. 1 and 5, see, they put it all towards the end right here. 1 and 5, 7 and 0, and we have to deduce the last numbers. Thank you, game, for... Is it 3 and 4? Okay, good. 3 and 4 are not paired together. So that's a successful trial right here. Now, some tips for this problem. You can only get multiples of 20% as an answer. We might have enough time. I bet we do. Yeah, we got enough time. Let's do it. Let's do it. So you can only get multiples of 20% as an answer. You can only get 0%, 20%, 40%, 60%, 80%. I have now obtained 40% because 2 out of 5 trials equals 40%. So 2 out of 5 trials is 40%. We'll cross our fingers. We'll hope I know how to do it. Woo! So scary. Not today, my Pearson. Not today. What do we say to my Pearson? Not today. Not going to trick us. Not today. So in this town, we live in a lottery with only 9 numbers on the ballot, I think, or 10 numbers. So the first thing we're going to do is we're going to look at this lottery card right here. And this is the last 35 days of the lottery, I believe. And we're going to find out which number occurs least often. So the number that occurs least often, here's a hint for the problem, only occurs 2 times. That's the way they generate it. So when we look, I see 9 occurring 3 times. I see 8 occurring a bunch of times. I see 7 occurring 3 times. I see 6 occurring 3 at least times. 5, wait. Okay, how many times does 5 occur? I need a, do you see I'm identifying the one that occurs the least often? It looks to me as though 5 occurs twice. Can everyone confirm 5 occurs twice? Good. 5 is my lucky number. I'm betting all my money on 5. Every day in this town, I'm betting 5. So there's 10 numbers I can bet on, 0 through 9. I'm betting 5. 5, 5, 5. Let's see how often I win. We go down here to the lottery, and once, twice, thrice. 3 times out of 20, not bad. So I won 3 times out of 20. Who knows the answer to the percent of times I won? I won 3 times out of 20. So the first step was find the least occurring number, and 5 was the least occurring. It occurred 2 times. Then once you pick your lucky number, see how many times you win in the next 20 days using your lucky number. Be careful, 3 times. Very close, very close. Unless there's a 4th time I'm missing. Good. I think it's 15%. Unless somehow I've... Yep. So the reason it's 15% is 3 over 20. It's 3 times out of 20 we had the number. And this one right here, just so we can get the full solve on the whole quiz. Whole quiz in this video now. Want a better picture of that. Perfect picture is what we go for. There we go. Look at that. Yep, got it. Sure. And let's go over here. So this one is a student. Hey, Brian, just wondering where the keys were on campus on the 474 homeworks. Yeah, I think I was talking to Dr. Lou about that, and let me make sure they're posted. So the graders have marked stuff. Are the keys not underneath the assignments? I think we have been posting stuff there. Let me look to see if they are there. Dr. Lou and I were communicating about that last night. And I believe we were putting them there. Yeah, they're there. Mm-hmm. So the keys are there, I believe. So if you go to an assignment, tell me if you can't access them, but no wonder Dr. Lou must have been like, yeah, they're already there, because I thought they were there. I must be going mad. Going mad. And then you see here the solution set for it right there. Does that make... Oh, no problem, no problem. Yeah, it's confusing. There's like 20 places to click. It's like, is it under the modules? Is it under the assignment tab? No, I totally understand. My brain just sometimes don't worry. Because I emailed Dr. Lewis saying that I was like, wait a minute, I think they exist. And I was like, oops. No, you're welcome, Peyton. I think I need to email a student because they were asking about it too. Good question. See, I love it. I love being able to hop on, say, hey, and then let's go right here. Let's go look at this question. So this student has an 80% knowledge of questions. With an 80% knowledge of questions, they're trying to take a multiple choice test, and they're going to see how many they get correct. Now, the rules for this game, let's write the rules. Where's my rules? There we go. Rule 1. A number 0 through 7 is a right answer. Rule 2. 8 and 9 are wrong answers. So there's the right answers and the wrong answers. So when we go through and solve this, we need to see how many they get wrong. And let's look. They get those wrong. They get... Oh, that's much harder to do. Let's not... okay. They get those wrong. They get that wrong. That wrong. That wrong. Wow, that was a bad one. They get this wrong. They get these wrong. They get these wrong. They get that wrong. They get this. They are not getting lucky here. Those are right. This is how we grade. This is wrong, wrong, wrong. And it looks like those are right. So what you need to do now is figure out, you have 1 simulation, 2 simulation, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 20 simulations is 45%. So if my adding up is right, 45%, and we've done it. We have aced. I don't know why it doesn't show the answer when you do it, but we've aced the quiz 100% in about 50 minutes. So all the questions are in this video now. I have a playlist too, though, so feel free to check that out. I might go through a little bit more slowly or explain in another way that makes more sense, but I just made that playlist on the channel. And I think there's a question about 321C, right? Let's go back. I closed it off, didn't I? Let's go back over here to 321C. Where did I put them? I closed it. 2 seconds. 2 seconds. 320. I should have everything up. Say, Brian, come on. What is this? What are we paying for with this YouTube? Homework packet. Here we go. Homework packet 321C. Okay. Sounds like I'm saying 321. 320. Okay. And 1C. Oh, wow. Whoa. Which part? We might have to do this another time. Which part were you wondering about this? Are you, you're welcome. You're welcome. Thanks, Hunter. Were you the one who posted that, Hunter? Someone's really nice to me. You're welcome, Leia. So great job, everybody. Great work today. I'm trying to see which one. I can't do all of 320 right now. Where is the question about 320? C1, right? Oh, C1, right? Okay. Include the scatter plot with the regression line on it. Make this manually or with visualized models. The trajectory of point stream linear enough so that the regression model is appropriate for describing the relationship. Yeah, let's do that. Let's make the plot. So this is a really good problem right here to start with, because we're just going to take the variable name and let's go over here to R. And here's what we need to do. To make a linear model, we're going to go M save into LM Y tilde X comma data equals and the data frame name. So the name of the X variable is this, and the name of the Y variable is wins, and the data frame is the EX3 NFL data frame. Don't worry about that graphics error because I have the window so small. But speaking of, we need a bigger window here because there's a few ways to do this. My favorite and easiest way is to just go visualize model, and there we go. So for the web, so hopefully, does this make sense here, Jessica? This is the easiest way to visualize models. You can just do the y tilde x comma data equals. So you have your y variable, your x variable, data equals the data frame you're using, which is the EX3 NFL data frame. And then you just make, yep. And then you've got your linear model. Does the points, does the line seem like it goes through the center of the data? Does that line look to go through the middle? Like if this was a slice of pizza, that's why I want pizza. And then we were to cut through the middle of it. Does that line look to bisect the pizza slice? Some weird oblong pizza slice. And does that go through the middle of it at all points? It shouldn't wave around it. You can do it with plot. Plot is not nearly as fun. You go to plot y, or you go to plot and you take the formula right here. So you just use the same thing right here and you can plot it like that. And then you can go AB line M. So, and then you can make the color of this if you want. So you can do it this way and go to col equals red. So let me drop this in the chat right here. But this is how to do it with the plot, using plot, which I'm not a big fan of. I bet we could do this. Is it LW line width? There it is, I think. And line width equals 3, sure. There we go. So you can change it. I was saying, and then with the same X, you might have to post, yeah, if you post it here, I was saving wins, Y into wins, and then same with X. Yeah, use this right here, use the Y tilde X, comma data equals, and the data frame name, and use that format right there, and then just call the variables like this right here. We get you. Thank you for the website lottery question. If my lottery ticket doesn't have any number 5s, then would the number be 0%? Make sure for the website lottery question, do we still have that up? Make sure for the website lottery question that you pick the least likely number. So you will pick the number here that occurs least often. So you'll pick the least, does that make sense, Ashna, right there? You'll pick the number that occurs least often. So your number might be different than mine. You'll pick the least often number. 5 was the, oh, and then it never occurred? Yeah, 5 was the least likely then. And if it never occurred here, then it'd be 0. Wow, I don't think I've really seen that. But and take a screenshot if it's wrong or something, and I'll double check. Or you can just say, look at this question from Brian. But that's got it. Great job, Ashna. Great job, everybody. Really good office hours. We had, nearly 15, 20 people watching or something, or I don't know, at least a dozen I heard. But really proud of everybody and keep up the great work. So it's busy semester, but we've been doing really well, and I'm really proud of everyone. A lot of great grades and a lot of people working really hard. I did the question go 11 trials with which one you had 11 trials on. Which one do you have 11 trials on? The drawing the cards, is it for the, if you ever have 11 trials, delete the remaining ones. You should only have 10 trials. You should only have 10 trials for, if it says have 10 trials, you only have 10 trials. If you have more observations, just delete them off. Does that make sense, Gigi? If you have more observations for any of the simulations than it says to have, just delete them. Like in the states one, or the giving away money one, or the dice roll. I think that's got it. I think it's time for us to go. Oh no, I did this thing a long time ago. I'm like, goodbye, everybody. So that's my thing. That's what I do. This is my catchphrase. Goodbye, everybody. See you soon. Bye.